Hello everybody. Today I'm going to show you how to perform basic matrix operations on Python. So this would be a quick, short tutorial. So let's get to work. At first, go to Anaconda. And then launch Spider. What you see up here is, so on the left, I actually have a script, a set of lines of codes, and on the right I have the console. So 2 plus 2 plus 3, then 10 minus 2 equals 8. So you can do some math on the console, and you can also see the output on the console. So you see the output after you run your script. So on the left I have a script opened up, and if I hit the run button, I can see the outputs. Okay, so let's go ahead and see how we actually end up with all these outputs. Let's get to the script. Here on the left we have the script. I'll start this script with these up here: import numpy as np, import matplotlib.pyplot as plt, and something more. We actually need this to import the tools that we need to do all the computations. For instance, NumPy is a library, or you can say you can think of it as a package, and this package has what we need to form a matrix. So I've imported NumPy as NP. So next time I won't have to write NumPy in full form, but I can just use NP. Down below you can see how I actually constructed a vector v1. So I define v1 as np.array parentheses, and then inside the square bracket I have the entries. So v1, you can actually see v1 right here, 3, 4, and v2 is actually a column vector containing the same entries. v1 is a row vector, whereas v2 is a column vector, shown here. And the reason I actually can see the outputs is I actually printed v1 and v2. So this is the definition of v1, that is the definition of v2, and these are the commands I've used to print v1 and v2. As you can see, they're printed. Next, I go to form a matrix. So A is a matrix, and we can think of matrix as a higher dimensional array. A is defined as np.array, parentheses, parentheses, and then inside square bracket, inside the first square bracket, I put 2 and 3. And then I move to the next row. The entries in the second row are 5 and 1. I print A, and I see A let's check A. Yeah. So this is my A. 2, 3, 5, 1. Let's go to B. I've defined B using 2 and -1 in the first row and -1 and 2 in the second row. Let's print B. Note that the reason I can print all this stuff is I've already run this script once in the very beginning. Okay. And then I move forward and I try to print A plus B. Now that I already have A, B, I can compute A plus B, which is this. So I'm done with addition. I can also do subtraction. So A minus B, that's the result. I can even perform multiplication of matrix A and matrix B. So in order to multiply A and B, what I have done in the script is I have used this function called dot. So AB is equal to np dot A comma B. So dot is a function where the inputs are the matrices that we'd like to multiply. So np dot A comma B would give us 1, 4, 9, -3. So this is the product of matrix A and matrix B. At the very end, I'm trying to find the inverse of matrix A. Note that the functions dot and inv are already imported. So dot is right here. It was imported from numpy, and inv was imported from numpy.linalg. So this first step, where we actually imported something from the library or package, was really important. I imported the tools from these libraries or packages, and then we're able to perform the computations. Here I was trying to find the inverse of matrix A, so I wrote A-inv. I defined A-inv as the inverse of A, and here I try to print inverse of A. Let's do that on the console. A-inv is equal to inverse of A. Let's print. So this is the inverse of matrix A. Likewise, we can also find the inverse of matrix B. So this is the inverse of matrix B. As a check, what I can do is I can multiply the inverse of A and matrix A. So down here, I was trying to print the multiplication of A and A inverse. As you all know, if we multiply A and A inverse, we end up with the identity matrix. So let's check that out. Let's multiply matrix A and its inverse. See what we have gotten. We have gotten a matrix where we have 1 along the diagonal and the other entries are actually zeros. So something to the power -17 is a very small number, and this is already, as you can see, it's already 0. So this is the identity matrix. Okay, let's just summarize. On the left, I have the script. You start a script by importing the tools that you need to do the calculation, and you would have to import these tools from the libraries. So NumPy is a library. Matplotlib.pyplot is another library that we will see will be really helpful when we're trying to plot something. But in this tutorial, I did not show any application of this library. I just imported this tool from this library, and down here I actually tried to illustrate some of the basic operations, some of the routine operations that we do when we work with vectors and matrices. So that's it for today. I hope you will find this tutorial helpful. Thank you.